Okay, so before we look at this next example, let's just draw a triangle here and mark it up. Okay, so this will be angle A, which means the side length of side A is over there. And up here we'll put B. So it's length there, and then angle C has the little c length on the opposite side. And let's just pick one of these. Let's take A. So my law of cosines, I'm going to build it for the A squared on the left-hand side. So it equals the other two squares added together minus twice their product times the cosine of the angle opposite A. Okay, a lot of times what we want to do is get the cosine of A solved for. So all I'm going to do is move everything over to the other side and isolate cosine of A. And that way we can see what pattern develops there. So we're going to subtract c squared and b squared on both sides. Okay, so we end up with a squared minus c squared minus b squared is equal to negative 2 times c times b times the cosine of A, big A. And we'll divide both sides by negative 2cb. Okay, so this is going to divide out and make this side just equal to cosine of A. Over here, I'm going to multiply this by 1 in the form of negative 1 over negative 1 just to get the sign in the denominator non-negative. Okay, so this would end up being, if I distribute this to all these, I would get c squared plus b squared minus a squared, and that allows me to make this 2cb down here. Okay, so if we're looking at A, and this pattern is just going to transfer to each of the pairs of angles and lengths. Okay, so we can think of this generically. Let's say now I don't want to go through all that trouble again, but I want to know how to write cosine B. Well, it's just equal to the sums of the other two lengths after they're squared minus the square of the length associated with this time angle capital B, and then down here it's twice the product of the other two. So I could write this as a squared plus c squared minus b squared, because that's the angle, over 2 times a and c. And lastly, if we're looking for cosine of capital C, it's going to be the other guys, so a squared plus b squared. In the minus, we subtract the length associated with our angle over here, and then we divide by twice the product of the other two. Okay, so we've got this clarified for any situation. So let's take a look at using this. Okay, so here's a chance to put this work to some use here. All we know about this triangle is that one side's length is 6, one side's length is 3, and one side's length is 4. So we can go ahead and place them where we want. So I'm going to put the C length over here. It's the longest. And then for A's length, I'm going to put it over here. It's the second longest. And then B down here. All right, so that dictates that our angle capital A has to be here, and then the angle opposite little c is big C, and the angle opposite little b is uppercase B. All right, and what we know are just these sides. So A is equal to 4, C is equal to 6, and B is equal to 3. Now we don't have any of the angles, so we could really just kick in with whichever one we want. So in this case, I'm just going to start with finding angle A, and I know that A's cosine is equal to C squared, so we got 36 plus B squared, so that's plus 9, minus A squared, so minus 16, over 2 times C and B, so that's going to be C times B is going to be 18, and then we need to double that, so down here we're going to get 36. Okay, so simplifying this result, we've got 29 on top, over 36 on the bottom here. Okay, so since the cosine of A is 29 over 36, A itself would be the inverse cosine of 29 over 36. All right, so here we go. We've got degree mode, and I'm going to take the inverse cosine of 29 divided by 36, and that renders an angle of about 36.3 degrees. Okay, now let's move on and get the cosine of B, set that up. So over here I'm going to say the cosine of B will be equal to A squared, so that's going to be 16, plus C squared, and then minus B squared, so we're going to say minus 3 squared, or 9, and that's going to be above twice the product of A and C. So if I take A times C, I get 24, and I have to double that, so down here we'll have 48. Okay, and so totaling these, we get 43 over 48. So since the cosine of B equals 43 over 48, we know that B is equal to the inverse cosine 43 over 48. So we're looking at about 26.4 degrees. And then I could go up here and use this for C, but since I've got 2 of the 3 interior angles and we know that they add up to 180, I can just figure out C's angle by subtracting A and B from the 180 total. So our total here is 117.3 degrees. All right, so we have A is roughly 36.3 degrees, B is roughly 26.4 degrees, and C 117.3 degrees. It gave us all the lengths. We have all the angles, so this is a solved for triangle.